Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube channel. Today we're going to be going over the properties and states of matter, so please make sure that you're filling in your notes as you go. As you can probably guess, our very first state of matter that we're going to be talking about today is solid. So the key thing that sets solids apart from other states of matter is that they have their own definite shape and they have their own definite volume. Now what that means is that the particles in a solid are very tightly packed, which means they're very close together. So you can assume that they're almost touching each other. They also don't expand very much when they're heated. When we're talking about heat expansion, what we're talking about is the vibration that solid particles have. So they'll vibrate a little bit more when it's warm, which is what these sort of like weird lines are meant to represent, but they're not going to expand as much as the other states of matter would. Also, it says that they are incompressible, which means that they can't be pressed into a smaller volume. It's very difficult to apply a force to a solid and have it take up a smaller volume because the particles are already so close together and tightly packed. Our next state of matter is liquid. So it's a form of matter that has a constant volume and no definite shape. So what makes that similar to a solid is the fact that there is a constant volume. But unlike solids, they have no definite shape. The reason they have no definite shape is because they're not as closely packed as solids are. So instead of being in a nice little organized, almost crystal-like structure like our solid was, they have a little bit more wiggle room. And so because they have more wiggle room, that means that they're actually able to move past each other. This special ability for liquid particles to move past each other is called flow, which is often why we talk about water flowing in a river or something along those lines. Also, liquids will take the shape of whatever container you place them in. So whatever the shape of the container is the shape of the liquid, which is why it has no definite shape. Our last state of matter that we're going to be talking about are gases, and so they have no definite volume and no definite shape, which makes them similar to liquids, but not necessarily similar to solids. The thing that sets gases apart from each other is literally the fact that they are so far apart. So solids had a very organized structure and were very closely and tightly packed. Liquids were not as tightly packed but still had some wiggle room and structure there. Gases, on the other hand, are extremely far apart from each other. So that means that they have very little structure. Because of the amount of distance and space between most gas molecules, that means that most gases are considered compressible, which means that you can push them down or you can compress them into a smaller volume because there's so much space that these gases take up normally. Also, if you heat up a gas, they will expand drastically. So these gas molecules will start moving faster and faster and move further and further and further away from each other. Now that we know the three states of matter, we have to talk about their properties. And so the two types of properties that we're going to be talking about are physical and chemical. The first are called physical properties, and these are characteristics of matter that can be observed or measured without changing the matter. In other words, if you just have a chunk of something, you could identify its physical properties. You don't need to add a chemical to it or mix it with water or do anything to it in order to figure out what sort of characteristics or properties it has. Now, physical properties can be broken up into two categories. The first are called extensive, and the second are intensive. Extensive properties depend on the amount of substance that you actually have. That means that extensive properties can change. Intensive properties, on the other hand, it does not matter how much you actually have, so they do not change. And that is the gigantic difference between the two. And it's going to seem a little bit confusing, but when we start going through examples, it'll make a little bit more sense. So just think extensive can change, intensive cannot change. Now in your notes you have a Venn diagram, so please fill in the following information. On the left side, put down this definition: depends on the amount of matter in the substance. On the right side, put down does not depend on the amount of matter in the substance, because that's the key difference between an extensive property and an intensive property. Now, the two similarities between the two can be written in the space in between. So what are the two similarities? They can be observed, changed, or measured without altering the identity of the substance. Well, what is that? That is the definition of a physical property. So both extensive properties and intensive properties are still physical properties. Now, in addition to that, they can both be used to observe and describe matter. So you probably want to pause the video at this point and make sure you write that down before we start doing examples. So leave a little bit of room in the space on your Venn diagram underneath your definitions there so that we can start to fill in some examples. Alright, so I've written down 8 different properties that can either be categorized as extensive or intensive. So we have size, mass, color, smell, shape, state of matter, boiling point, and length. So 4 of them can be classified as extensive, and I'm going to use the color green to represent extensive, or intensive, which I'm going to be using blue to represent. So let's go with size first. Is size an extensive property, or is it an intensive property? So just think, if you have a substance, and it doesn't matter what it is, it could be a chunk of copper, it could be a glass of water, but think about the term size. Is size a property that depends on how much you have? So is it something that changes, or is it something that is always constant? Well, depending on how much you have, it does change. You could have a whole bunch of copper, or a whole tub of water, or you could have a drop of water, or just a tiny, tiny piece of copper. So size is considered an extensive property. So you can put that in your Venn diagram. Let's take a look at mass. Is mass a property that changes, or is mass a property that doesn't change? So mass is, remember, how much stuff there is inside of something. So again, if you have a sample of copper, or if you have a glass of water, would the mass change, or would it stay the same depending on how much you actually have? Well, if I have a glass of water, or if I have a tub of water, they're going to weigh different amounts. They're not going to be the same always. So that means that mass is also going to be considered an extensive property. What about color? Does color change, or does color stay the same? If I have a glass of water, would the color be the same as if I have a tub of water? If I have a whole bunch of copper, or if I have a tiny piece of copper, would the color change? The answer is it doesn't change. It stays the same. So that would be an intensive property. What about the smell of a substance? Would the smell change if I had a lot, or if I had a little bit of something? The smell is also an intensive property. It doesn't change. It's consistent. What about the shape of something? Would the shape of something change if I have a lot or if I have a little bit of it? Well, I could have, like I said, a whole chunk of copper or just a tiny fragment. The shape is not something that's consistent. It would depend on how much I have. What about the state of matter? If I have a lot of water or if I have a little bit of water, does that change the state of matter? It doesn't. It's something that is consistent, so it stays the same. What about the boiling point of a liquid or the boiling point of a solid? Okay? If I have something, would its boiling point change if I have a little bit of it or if I have a lot of it? It would not. The boiling point is consistent regardless. What about the length of something? Would the length of something change if I have a lot or a little? Yes, it would. If I have a very long length of cable of copper, then I would have a very long length. If I have a very small cable of copper, it would have a very short length. And so compare all of these things to each other. We have size, mass, shape, and length. Those are all things that change. Color, smell, state of matter, and boiling point, those are things that are consistent regardless of how much you have. And that's the big difference between extensive and intensive properties. Now we're at the tail end of the video, which means that we have to talk about chemical properties. So physical properties are properties that can be observed without changing the matter itself. So all of those things we listed, size or smell or color or boiling point, those are all things that we didn't actually have to change something in order to observe it. Whereas chemical properties, you actually have to observe it when you combine it with other substances. And so you actually have to do a reaction or something in order to observe a chemical property. So, for example, iron rusts in the presence of oxygen. Rusting, like this right down here, is something that you wouldn't know unless you mixed iron with oxygen. Strong bases react with acid, like this picture over here showing a pink coloring. That is something you would know unless you mixed the two together. Also, sodium explodes when it hits water, just like here. You wouldn't know that unless you mixed sodium with water. So physical properties are things that we can observe without actually needing to do any chemical reactions. Chemical properties, on the other hand, are things that we actually need to mix something with another substance before we can see the result.